Welcome to GER Home Mathematics and Statistics lessons. In today's video, I will be talking about correlation and regression. Correlation and regression. So we want to understand the difference between correlation and regression and develop certain things that are important under these concepts. Okay, now that being said, please, I want to say a very big thank you to all of you out there who have subscribed to this channel. Thank you for your support. Thank you for your likes to our videos. Thank you for your shares of our videos. Thank you for everything you have done for this channel to endeavor that we grow beyond bounds. I am very grateful. For those who have been watching our videos without subscribing, please endeavor to subscribe to the channel. It is very important so that you get notifications on what videos we shall be uploading next. That being said, now let us begin. For us to understand the difference between correlation and regression, or to understand the concepts of correlation and regression, it is important we start with discussing certain key concepts. What are those key concepts? I'm going to start this video with discussing three things: bivariate data, univariate data, and multivariate data. So let us see what the difference between these three things are. So I'm going to write here 1, 2, and then 3. Now, I'm going to start with talking about what we call a univariate data. Okay? Next, I will discuss what we call a bivariate data. And then finally, I'll discuss what we call a multivariate data. Now, if you must understand the idea of correlation and regression, it is very important you understand this, and this. Okay, so let us start with this. Let us start with the concept of univariate data, followed by the concept of multivariate data, and finally the concept of bivariate data, and finally the concept of multivariate data. So what is a univariate data? Now I'm going to explain each of them, giving you real life examples of what we mean. Now let us assume this. Let's start with the first one, a univariate data. So what we call a univariate data is a data, okay, involving a consideration of one variable in relation to a particular thing. Okay, so a univariate data is a data involving a consideration of one variable in relation to a particular thing. What does this mean? Let's assume that there is a class of students. There is a class of students, and in that class, so for the particular thing we are referring to, let's assume that what we want to consider is one variable. If you want to consider a variable like height in relation to one thing, students, or one group of objects, students in this case, the data you obtain, height, that is, let's assume that there are n values because there are n students in that class, or let's be very specific, let's assume that there are 5 students in that class. Certainly we would have x1. If x represents the variable height, then we would have x1, x2, x3, x4, and x5 height measurements taken on the 5 students, students 1, 2, 3, 4, and 5. So when you consider a variable, just one variable, in this case height, in relation to a particular thing or object, in this case students, you are discussing this kind of data you obtain are called univariate data. So in this case, you may have the height of a boy, let's say 7 foot. Here you could have another height 6. You could have this one to be 4.5. You could have this one to be 5. You could have this one to be 5.3. If these are the heights of the 5 students, then this will make a univariate data, simply because you are talking about the variable, one variable in relation to a particular group of objects, in this case students. Okay, now so a univariate data is a data involving a consideration of one variable in relation to a particular thing. Now what if we go beyond one variable? What would it be? So we may end up having a bivariate case or a bivariate data. So a bivariate data is a data involving a simultaneous consideration, okay, of two variables in relation to a particular thing. So in a univariate case, we considered one variable in relation to a particular thing. Now, take note, it is just the same thing as me for a univariate case taking the scores of students in mathematics. So in this case, the scores may be my x, the variables will be the values of their mathematics scores, okay? The variable will represent their scores in mathematics. So you could have for 5 students 5 different scores, and that data will be a univariate data because we are considering just one variable, in this case mathematics scores, in relation to students. Okay, now what if we want to consider not just one variable in relation to a particular thing but more than one, in particular 2? If you consider 2 variables in relation to a particular thing, you will be talking about a bivariate data. Okay, you will be talking about a bivariate data. Now let's give an example of that. So you end up having, in this case, let's say x will be the height. Let's assume that x represents the height of students, and let's assume that y represents their weights, the weights of students. Okay, now what are we doing? We are considering the heights and weights of students in relation to students, the object. Okay, so let's assume that there were 5 students, 1, 2, 3, 4, and 5. If there were 5 students in that class, then you could have x1, x2, x3, x4, and x5 as the different heights for each of these boys, and you could have y1, y2, y3, y4, and y5 representing the weights of these 5 students. So when you consider the height and weight of these students in relation to students, the height and weight of all of them in relation to students, then you are talking about a bivariate data. So a bivariate data is a data involving the simultaneous or a simultaneous consideration of 2 variables in relation to a particular thing. So in this case, the particular thing we are referring these 2 variables to is students. Okay, now there are other examples you can actually look at aside these ones I'm giving as an illustration. So I want you to understand that. Now, what if the number of variables we are considering in relation to a particular thing is more than 2? That will give us what we call a multivariate case. So a multivariate data is a data which simultaneously considers more than 2 variables in relation to a particular thing. Okay, so in this case, when you consider more than 2 variables in relation to a particular thing, it gives us what is called a multivariate data. Now, you could also give an example if we continue along that line, that we have height, we have weight, okay, and we now have let's say score, mathematics score. Let's call this variable z, and let's call this variable z to be mathematics scores. So if you consider the x variable height, the y variable weight, the z variable mathematics, and so many other variables, all in relation to students, one particular thing, those variables, or the data in this case generated, will be called a multivariate data, because it involves the simultaneous consideration of more than two variables in relation to a particular thing. Okay? And what is the thing in this case? It is students. Now, I hope that is understood. Let us now progress. So let us quickly look at it again. So what is a univariate data? It is a data involving the consideration of one variable in relation to a particular thing. What is a bivariate data? It is a data involving the consideration, the simultaneous consideration. Simultaneous in the sense that you are considering both of them at once. So it is the simultaneous consideration of two variables in relation to a particular thing. And I've given you illustrations in this case. Now, what is a multivariate data? A multivariate data in this case will now be that which considers more than two variables in relation to a particular thing. And for example, you may have X representing height, Y representing weight, and Z representing mathematics scores, all considered in relation to students. So students will be the thing or object we are referring to, and these are the variables in relation to students. When you take more than two in relation to students, it becomes a multivariate data. But when you take two in particular in relation to students, it is actually a bivariate data. If you take one, just height in relation to students, it is a univariate data. Now, that being said, let us now go to the next discussion. Okay, so what next are we going to discuss in this video? Now, in this video, the next thing I want to discuss is the idea of what is called a scatter plot. Okay, what is called a scatter plot or a scatter diagram. So that is the next thing I want to discuss. Remember, our focus in the end will be to clearly define correlation and regression. Now, what is a scatter diagram? So I'm going to define it this way. What is called a scatter diagram? What is called a scatter diagram? What is called a scatter diagram is a graphical visualization. So a scatter diagram is a graphical visualization of a bivariate data in this case. So a scatter diagram is a graphical visualization of a bivariate data. Now, why are we focusing on a bivariate data? Why is our focus on a bivariate data? Our focus is on a bivariate data simply because of what I'm going to explain now. Now, when you talk about a bivariate data, it means we are now looking at two variables in relation to a particular thing, specifically two variables in relation to a particular thing. Now, the question we want to answer is this. What if you consider a variable like height, okay? If you consider a variable like height and another variable y, the weight of students. That is, so if you consider height and weight of students, that is height and weight in relation to students, then it obviously would give you a bivariate case. Now, when you want to answer the question, what is the relation? Is there a relationship between or any association whatsoever between X and Y in relation to students? When you want to answer that question, then you may as well use what is called a scatter diagram to give you a very graphic visualization of what is going on. What does that mean? When you want to answer the question whether or not there is an association between X and Y, the task may be 1. We want to know if an increase in X would also prompt an increase in Y, meaning that the height of students has a direct relationship with the height and the weight of students in that class. So the taller the student, the larger or the bigger the weight of the student. Now, that may be one consideration of association. So when we want to consider if there is any association whatsoever between X and Y, height and weight, it may be that we want to investigate if an increase in the height also determines an increase or provokes an increase in the weight. Another consideration may be, could it be that an increase in the height results also in a decrease in the weights? That may be a second consideration to determine association between x and y, the two variables. Remember, a scatter diagram is a graphical visualization of a bivariate data. Another question may be, to understand the association between x and y, another question to answer may be, is it possible that x and y have no association? No association. Is it possible? So that may be another consideration. Okay? Now, even as you keep these associations in mind, 1, 2, and 3. Another consideration may be, when you use a scatter diagram as a graphical visualization of a bivariate data, it boils down to wanting to know the association between the two variables. Is there any association between the two variables in such a way that an increase in one causes an increase in the other one, an increase in one causes a decrease in the other one, or there is no association at all? That may be one consideration. A fourth consideration may be, is the relationship between x and y, is the relationship between x and y linear? That is one question you may want to answer. And 5, is the relationship between x and y non-linear? So these 5 things I have mentioned are things that you can get directly from a scatter diagram. Let us reiterate. A scatter diagram is a graphical visualization of a bivariate data. What did we say a bivariate data is? A bivariate data is any data that considers simultaneously two variables in relation to a particular thing. And in this case, it may be that we are considering the height of students and weight of students in relation to students. It may be that we are considering the scores of students in mathematics and the scores of students in English in relation to students. So what we want to know in these cases could be, does the score of a student in mathematics increase? If a student has a high score in mathematics, is it possible that because he or she has a high score in mathematics, the student will also have a high score in English? If a student has a high score in mathematics, is it possible that the high score in mathematics will provoke the student to have a low score in English? If a student has a score in mathematics and another score in English, is it possible that the two scores do not even relate at all? One does not determine the other. Okay? That may be a third consideration. A fourth consideration may be, is the relationship between the mathematics scores and the English scores, the height and the weight, is the relationship linear? Or in 5, are the relationship between those two non-linear? That is what a scatter diagram can help you visualize. So, how does a scatter diagram look? A scatter diagram is simply a plot between the two variables. So, if we are considering two variables x and y, what we call a scatter diagram looks like this. Okay? It's a plot between the two variables x and y. In this case, it could be that my y are the weights and my x could be the heights. So if you plot a scatter diagram, it will give us several points within this space. Okay? A plot of the scatter diagram will give us several points within this space. So this is what we call a scatter diagram. A scatter diagram looks like this. It is a plot of one of the variables against the other variable. Okay? Now, Remember that a scatter diagram is a graphical visualization of a bivariate data. Graphical visualization in the sense that we use a picture, a graphical picture, to show that to show whether or not there is a relationship or association between two variables that are considered in relation to a particular thing. In this case, y and x, okay? Where your y may be the weight and your x the height of student, or your y may be the mathematics scores of student and your x the English scores of student. So a bivariate data would can be visualized using what is called a scatter diagram or a scatter plot, and that scatter plot is otherwise a graphical visualization of the bivariate data. So let us quickly look at it again. So what a bivariate data will do, a scatter diagram will do for us, is to tell us whether or not an increase in x will cause an increase in y, an increase in x will cause a decrease in y, an increase, what do you call it, a relationship in between x and y exists or does not exist at all. Or it may show us that the relationship that exists between x and y is linear, or the relationship that exists between x and y is non-linear. Okay, so that being said, let us go to another consideration. The next consideration I want us to focus on is, if we now know, if we have just talked about it, that a scatter diagram can show us when a relationship between x and y is such that an increase in x provokes an increase in y. So if that happens, then you would end up having a scatter diagram like this. So if it happens that there is a relationship between the variable x and y such that an increase in x causes an increase in y, then you would have a scatter diagram that looks like this. Now notice the direction, notice the general direction of the points. You will notice, if you can put a line among these points, you will notice that that line is actually going upward. The line is going upward, telling you that an increase in y provokes an increase in x. Okay? So a scatter diagram can actually help us visualize this case. Now, when it happens that using a scatter diagram, when it happens that there is an increase in y causing an increase in x, then we call this a positive correlation. Now remember, we are yet to define what correlation is, but I'm going to use the language there. When it happens that with the scatter diagram, we notice that an increase in y causes an increase in x, or an increase in x causes an increase in y, that kind of correlation is said to be positive using a scatter diagram. It may also happen that we want to describe a case where an increase in y causes a corresponding decrease in x. In that case, your points plotted with the scatter diagram will be seen to go in this direction. You will notice that if you can put a line, that line will be such that it descends. Okay, it descends, and in this case we say an increase in one of the variables, in this case x, an increase in y rather, an increase in y provokes a decrease in x. Okay, and in this case we would say the scatter diagram is actually visualizing, helping us visualize what we can call a negative correlation. Okay, now a scatter diagram can do a third thing. So in the first instance, what can a scatter diagram do for us? It can show us that there is a positive correlation between y and x. Two, it can show us that there's a negative correlation between y and x, the two variables, the bivariate data. Okay, and in this case, for an increase in x in y provoking an increase in x, or an increase in x provoking an increase in y, we say there is a positive correlation. Notice that the line ascends. Okay, it ascends. But when an increase in y provokes a decrease in x, the line descends. Okay, so this diagram here represents positive correlation. This one represents negative correlation. Now, if you go over to a third case, let us look at a third case, what a scatter diagram can do for us. Now, a third case is that a scatter diagram may show us that there is no relationship at all. That is, it may show that there is zero correlation. And in this case, the plot, the plot of the points using the scatter diagram will be something of this nature. You will notice that with these plots, these scatter points, you will notice that there is no clear direction in which the points are going, whether upward or downward. There is no clear direction. Okay, in this case, when it appears in this manner using the scatter diagram, let's call this a case C, you will notice that this can be described as a zero correlation case, because it shows us that there is no correlation between x and y, since there is no clear direction based on that line between showing that x and y is such that y increases when x increases, or y increases and causes a decrease in x. Now, these three cases, case A, case B, and case C of a scatter diagram can all be described as linear. Okay? Linear, especially because we can actually fit a straight line across the points. Or you can put it the other way around. Okay? You can put it the other way around, that A, B, and C are linear because the points that are plotted using the scatter diagram all converge about a particular line, a particular straight line. What if the points plotted on the scatter diagram do not converge around a particular straight line? Rather, they converge about a curve. What if it happens that this is what we have? What if it happens that this is what we have? Okay? What if it happens that this is what we have? We have it such that you have a non-linear case. Okay? Such that you have your points. The points that are plotted go in this manner. Looking at the points, you will notice that the points happen to not cluster around each other. But if you look at it critically, the points do not go upward in any upward direction or downward direction or vague direction, whether in this one or this one, but the points appear to be converging about a curve. In this case, when the points you plot using your scatter diagram appear to be converging about a curve but not a straight line, the scatter diagram in this case is called a non-linear case. No more a linear case. Remember, if we call this case D is a non-linear case which the scatter diagram describes. But case A, case B, and case C are all regarded as linear cases because the points you have plotted using the scatter diagram appear to be converging about a straight line. This one that is a zero correlation still can have lines fit in any direction. It is zero correlation because you cannot actually see the clear direction of the line. Now, the last thing I want to say that we are going to continue from in our next discussion is, if you look at case A, case B, and case C, in which the points can be said to converge about a straight line, this straight line is called a regression line. This straight line about which the points appear to be converging is called a regression line. In our next video, I'm going to give you details about a regression line. So these are called regression lines because they are straight lines about which the points plotted in the scatter diagram appear to cluster about. What if we want to look at case D, that is a nonlinear case, in which the points appear to cluster not about a straight line, but about a curve? This curve around or about which the points appear to cluster is called a regression curve, not a regression line, a regression curve. But the focus of this video or our videos or our discussion on correlation for now is not on regression curves, but rather on regression lines. And that is what we are going to be discussing in my next video on correlation and regression. So this will be a part 1 video on correlation and regression. Now, let us quickly go to the last thing. That being said, about correlation and regression, I'm going to say this, which shall continue in my next video on correlation and regression. So, having said that so far, what are we actually to summarize? We can summarize with now defining correlation. So, let us now answer the question, what is correlation and what is regression? I'm going to give this definition and then give you an explanation using real life examples. Okay? So, what is correlation? What is regression? Now, correlation simply, in my own definition of correlation, is a study or a measure. Correlation is a statistical concept. Okay? It is a statistical concept that discusses a measure of the level of association or relationship between two or more variables. Okay? Now, if you want to look at it critically, you will notice that correlation talks about the concept of discussing the measure of the level of association or relationship between two or more variables. What does that mean? It means that it is in correlation we discuss whether or not two variables are related or associated. It is in correlation we discuss that. Are they related? Are they associated with one another? That is number one. Number two, it is also in correlation that we discuss how they are related. Okay? In the sense that is an increase in y causing an increase in x, or an increase in y causing a decrease in x. It is also in correlation that we discuss that. But in regression, although similar to correlation, does something almost different from correlation. Regression is a statistical concept also. It is a statistical concept that models or discusses the modeling of the relationship or association between two or more variables. So, whereas correlation talks about the level of association, a measure of the level of association between two or more variables, regression talks about the modeling. Okay? Now, if you want to look at it in this manner, you can look at it from this angle. Let us assume that there is a boy and there is a girl. Okay? Now, in correlation, we check this about these two people, the boy and the girl. So it is in correlation we say that they are related or not. It is in correlation we answer the question, are these two people, the boy and the girl, are they related? It is in correlation we answer that question, are they related? It is also in correlation we answer the question, what kind of relationship, or how is their relationship rather? Is it strong or weak? not what kind. It is in correlation we answer the question, are they related to start with? And it is also in correlation we answer the question, how strong is their relationship or how weak is their relationship. But in regression, we no longer ask that question or answer that question. It is in regression we answer the question, what is the kind of relationship existing between, now that we know that the boy and the girl are related, or their relationship is weak or strong. It is in regression we now say that both of them are dating. Both of them are a couple. So it is in regression we answer the question, what kind of relationship exists between them? Are they siblings? Are they siblings? Are they dating? Or are they relatives? So, or are they colleagues? So, it is in regression we answer the question, what kind of relationship exists between this boy and this girl? But it is in correlation we answer the question, are they related? So, are they related is answered by correlation. What is the strength? What is the strength of their relationship? This is another question answered by correlation. But in regression, we answer the question, what kind of relationship are they involved in? What kind of relationship? So that being said, let me quickly summarize. Correlation is simply a statistical concept that discusses a measure of the level of association or relationship between two or more variables. But regression is also a statistical concept that discusses the modeling of the relationship or association that exists between. It is a statistical concept that discusses the modeling of the relationship or association that exists between two or more variables, whereas correlation measures the level of association or relationship between two or more variables. Okay, so that being said, thank you very much for watching this video. Please smash a like on our video and do subscribe if you haven't subscribed. Thank you very much, and thank you very much.